Hello everybody, welcome to my channel. Today we have a very good problem for you guys called count nodes equal to average of subtree, right? So this is a very good problem, so make sure to pay close attention to the problem statement, right? So it says, given the root of a binary tree, I return the number of nodes where the value of the node is equal to the average of the values in each subtree, okay? So they're giving us some good notes for us to really kind of understand what they mean, right? So the average is meant, what do you mean by average, right? Is the average of n elements, right? Is the sum, right, of n elements divided by n rounded down to the nearest integer, right? This is a very good, important key concept to understand for this problem, right? So you say a subtree of root is a tree consisting of root and all of its descendants, right? This is a very good thing that they're letting us know, right? What do you mean by the subtree? It also includes the root as well, right? You know? Okay. So whatever subtree that we're looking at, I rooted at that subtree. The definition right says, the root is also included as well, right? In whatever calculation we end up doing, right? So the ask for this problem is pretty clear, right? So let's go through a couple examples to help really solidify the ask, right? So you see that we were given this example one, right? And our job is to return the number of nodes, right, that pretty much meet a certain criteria, right? So the criteria that we need, that it needs to meet, is that it needs to be equal, right? So the node, right, needs to be equal to the average of, of its subtree, right? And the average of the subtree is calculated by the amount of nodes in that subtree, right, divided by no, the sum of all the nodes in that subtree, right, divided by the number of nodes, right, in that subtree, right? So for the subtree rooted at 4, right, the root node, um, adding up all the values in the binary tree, right, pretty much, right? Pretty much you do 4 plus 8, 12, 13 plus 0, 0, right? 13 plus 5, 18, 18 plus 6 is 24, 24, right? So we have a 24, sum of all the values, 24, right? For the subtree rooted of 4. What we need to do is, how many number of nodes do we have, right? We have 1, 2, 3, 4, 5, 6. We have 6 nodes, and that's how we end up doing 24 divided by 6 equals to 4, right? So let's see for the subtree rooted at 5, right? Same concept. We do 5 plus 6 is 11. It doesn't have a left child. So therefore, 5 plus 6 is 11 divided by how many number of nodes? 2, right? So we end up dividing by 2, and then we end up with 5.5. We remove the decimal because we round it down, right? And then we just end up with 5, right? So that's 1 there. And then we do the same thing for 6, right? There's nothing on the left, nothing on the right. So 6, right, which is the sum of all the values for the subtree rooted at 6, right, divided by 1, right? That's why because it's only one node, right? So that's why we have 6 here, guys, right? So it's equal to a subtree, so it counts as those, right? So pretty much the same thing for the other ones, right? So there are 5 nodes in the entire subtree that meets this particular criteria that they're looking for, which is the node is equal to the average of all the values in each subtree, right? And they've given us the definition here, right? So pretty easy to understand, right? So how do we go ahead and solve this particular problem, guys, right? So how do we do it, right? What kind of traversal that needs to get done, right, for us to really kind of solve this the most appropriate way, right? So what I'm thinking here, right, we can have, right, which traversal. So it seems like I need to, so a pre-order wouldn't work, right? Because I need to know the information from my children, right? My left child, my right child as well, right? I need to know these type of information, right? And after I know this information, then I can make a decision by doing some calculation, right, to decide for a node rooted at that node, right, if it's equal, that subtree, right, does that node equal to the average of all the values in that subtree, right? Okay, that's kind of what I'm to do. So I need to explore my left side, my right side, right? And then after that, make a decision, right, if that node fits that criteria or not, right? By doing the calculation, which is summing, having the values about sum of all the nodes on my left side and right side, right, and then including myself as well, right? So how would I do this, right? So pretty much I explore my left side, right? Boom, boom, boom. So I get to 0, right? 0 now. We gonna hit the base case, right? We return 0. So for that subtree, right, what do I need to know, right? So now that I've seen the calculation, what piece of information, right? Is it only one dimensional where I only return one number, right? Because if I choose to return only the sum, right, so 0 returns 0 to this guy, right? And it has, sorry, no, the sum for my left side is 0. The sum for my right side is 1, okay? Then how do I calculate the average, right? So how do I do it? So I do 8. How do I know the number of nodes on my left side, right? Right? Because I need that as well to make the calculation, right? So this one you might say, oh, it's obvious, man. Just do it's only one side, one on the left side, one on the right side. See, it's not that obvious, right? So let's say we had 4, right? This obviously not 4, right? And I need to know how many. What's the sum? I need to know those two pieces of information, right? The number of nodes on my left side, and also the sum of all the nodes on my left side as well, right? See, it's not that, right? So what we'll have to do, right? Seems like we need to return two pieces of information, right? So each node will return to me, right? So I can make the right decision. Because if I only return the sum, then I need to know, I won't have the information about the number of nodes that I have, right? Likewise, if I return the number of nodes and I don't have a variable or whatever thing to keep track of the sum, right? It won't work out. So what we're going to end up having to do is return two pieces of information, guys, right? To the color, pretty much, right? So what I will return, right, is the so each guy will return, right, the sum of all the nodes, right, rooted at that particular node, right? So 8 will be x, so 0, okay, for that, rooted at the subtree rooted at yourself, right? What's the sum of all the nodes there, right? It will return that, right? And also return to me, right? So I can make a right decision. The amount of nodes present, right? After I get those two pieces of data, right? I'm pretty much home free. I just calculate the average, right? Yeah, so just say, all right, the sum, right? I have the sum and I have the number of nodes. Then just calculate the average and then check myself against it. And then cool, I have my answer right there, right? So this is just like that. I'm thinking it should be relatively simple. And if all the nodes that meet that particular criteria, I would just return yes. That's I would just do a count plus one with a particular counter, right? So that's kind of how simple I'm thinking about it. So let's quickly get into the code. I think it'll make a lot more sense. Let's go ahead and counter, right? And then we initialize that to counter to 0, right? Initially. And then we're gonna just pretty much use a hopper function to pass it the root, right? Then at the end, right, we just simply return the counter, which will hold how many nodes met that criteria, pretty much, right? It's kind of how I'm thinking about it. Okay, so what we're gonna do here is we have a private function, and we set that will pretty much return two pieces of data, right? Okay, so we're using an array. You can use a paired data structure. You can use a custom object, whatever. I could use different depending on your approach, right? It's up to you, right? So what I'm gonna do, I'm gonna just use a array, right, to keep it simple, right? So now we have our base case here, guys, right? So if root is null, what I'm gonna do here is to return new int, right? I need two pieces of data, right? So just copy it here so that it's very clear for you guys, so you guys can keep track. Okay. So I have 0, 0, right? So this is the sum of all the nodes. All right, and the amount of nodes, right? This is our base case pretty much, right? And then what I'm gonna do, go to my left side, right? And I need to know the data from my left side. So I pass in my left subtree, all right? And my right subtree, right? Okay. Okay, I got my right subtree. So what I'm gonna do is to now, right? I got those pieces of information I was asking for. So I calculate the sum, which is the sum is, like this, right? So the left side, right? So I'm capturing it in my first index, right? So index 0 plus the right side as well, right? Which is, they're all in the index 0, right? Because that's where I'm storing the sum of all the nodes, right? And then also remember that, right? When they mean that, subtree consists of the root node, right? So we need to also account it for it, right? So count root that val, right? So I have the sum, right, for that subtree. So now I need to also calculate the amount of nodes. And just do amount, keep it short. Pretty much we copy the exact same thing, right, So instead of that, right, we put a 1 here, right, to account for this node, and then this gets switched to a 1 as well, right? So this is where I'm storing, right? This is the amount of nodes, right? So I get the amount of nodes from my left side, the amount of nodes from my right side, right? Then I account for this root itself, right? Because it needs to be accounted for, right? And then now, right, we need to make our decision. Now I've got my pieces of data now, right? So this is where it comes to becomes helpful. So if this particular root, right, is equal to the sum divided by the amount, right? If that's the case, right, which is this is how you calculate the average sum of all the nodes in that subtree, right, rooted at that particular root, divided by the number of nodes, right? So if we get that case, then we do a counter plus plus, right? Right, and then after that, I'm pretty much I'm done. So I just need to return it to my parent, whoever called me, right? So that they themselves can use that whatever information from my subtree, right, to calculate for theirs as well, right? So for example, right, so 0 after calculating, saw that it is equal to plus 1, right? It will return to this guy, right? The sum, right? Of all the nodes, which is the sum. I already did that calculation right there, right? Which is 0, right? And the number of nodes. The number of nodes is 1. This is 0 because he has no left, no right, plus 1, right? Then we get the number of amount as well, right? And this is how every node ends up doing that, and then their parent has that information and can use that information to really make the right decision. So let's press run. Forgot to put this. Let's press run. Oh yeah, I forgot to put this right there. Let's press run. Looks good. Let's press submit. Awesome, guys. We're able to pass all the test cases, right? Looks like we get one of the best time complexities, right? So if you guys really like the overall process, the way they explained it, let me know in the comment section. If you guys are new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So thank you guys for watching, and I'll see you guys in the next video.